We know that a continuous uniform distribution defined on the interval 3 to 11 would appear as shown below. So we can see from 3 to 11, the probability is non-zero. In fact, it's 1/8 because the width is 8, 11 take away 3, and the height is 1/8. 8 times 1/8 is 1. And the probability is essentially 0 everywhere else. If we wrote this out, we could say that P of x is equal to 1/8 if x is between 3 and 11, and it's 0 everywhere else. If you're unsure about continuous uniform distributions, you should look back at those lessons. How would a sample drawn from this distribution appear? The simple fact of the matter is that they would vary. What we're going to do is we're going to take samples of size 20, and we're going to use the class pad to do this. So what I'm going to start with is I'm going to go to the keyboard, and I'm going to go to the catalog, and I'm going to choose RandList. Now, if I just put in RandList 20 and no specification of the range, what it gives me is 20 random numbers that are between 0 and 1. Now, before I actually hit the enter or execute on that, I'm going to just use this arrow just here, and I'm going to use the variable a, and I'm going to store that list in A. So I'm going to press execute, and you can see that I've got my list of random numbers between 0 and 1, and they have all been stored in a variable called A. Now, those are between 0 and 1. We want to draw random numbers between 3 and 11. So, what I'm going to do is transform the numbers we have, which are between 0 and 1, using 8a plus 3. So my original numbers are between 0 and 1. Multiplying them by 8 will now mean they're between 0 and 8. And then if I add 3, they'll be between 3 and 11 as required. So what I'm going to do over here is I'm going to do 8a plus 3, and I'm going to store that in a variable which I'll call b. And now what we should have is 20 random numbers that are between 3 and 11. Now, let's go to the statistics package. Anything we've got there, just clear it out. And list 1, I just want to replace that with B. And doesn't seem to have given me the right numbers there. So, no, actually it has. It's just put them in as fractions, which is surprising since I've actually got that as decimal. What did I have on main? That was decimal as well. So anyway, these are the numbers, and for some reason they're in here as fractions, but they're definitely the things that are in B. So what I'm going to do is try and get a picture of what this data looks like. So we want a histogram, but my x's need to be main B. leave the frequencies as 1, and we'll set. And then we're going to plot the graph. Now, let's make our H step maybe 1. And so we're going to do a histogram with widths of 1. And let's see what that looks like. So it looks something like that. But we know that the original distribution looks like this. Now what I've done is I've taken a picture, as you can see here, of that sample. And I'm going to do another sample to see if we can see the variability in the sample. So I'm going to go back to main, go here, and I'm going to produce a second list, and you should see that list change as well. So I'll do that again. You should see both lists change as we do that. And so if we now go back to the statistics package, and this list represents B, if we want to make sure that it has updated, we could, of course, go back to list 1 there and bring B in again, but I think it's different. In fact, let's just do it again and just make sure. 1, 2, 4, 1, 2, over this one. In all likelihood, you'll have decimal numbers here. Let's just go back to main and let's just generate that again. You can see the numbers are quite different. So when I go back to the statistics package, we can see that that is different. And let's just check that our graph is still a histogram, main B, that's all good. Let's generate this again. Let's change the width to 1. And we can see it looks quite different. So they're two different samples drawn from the same distribution, but they look quite different. What would happen if we took a bigger sample? A bigger sample should look more like this one here. So I'm going to quickly do that. And so let's do a round list of maybe 50. And we'll generate that. And now we should have 50 in there. If we go to the statistics package, we should now have 50 of these numbers. And we can see that's the case. And let's see what happens if we now draw the histogram. And there's still a bit of up and down in it. And it also looks different to the previous two. But bigger and bigger samples should look more like the original distribution.